Okay, so we're starting today with the Tambora volcano problem. So, as you can see from my sketch, there is a volcano and it is spewing ash. And the ash is leaving the volcano at a velocity of 625 meters per second. And what we're trying to determine here is how high will the ash rise? By the way, it's on the island of Sumbawa in Indonesia. Okay, so the second part of the question wants to know, would it have gone higher on the planet Venus, where there's slightly less gravity than there is on Earth? So we take it over here and we look at our givens, unknowns, and we see that our first piece of given information is that velocity is 625 meters per second. That's actually its initial velocity because it's being shot up into the air. Since this is going against gravity, the final velocity is actually 0. This is what we kind of left off talking about in class the last day that we were together in person, when we drew the person throwing the ball up in the air. At the peak of the point at which it rises to the highest point, it momentarily stops and converts from kinetic energy all to potential energy, and then as it drops down to Earth, goes back to kinetic energy again. So that was an important piece. It's a think aloud here. So you might want to, that's something that wasn't in the problem. You have to think about that. And because it's an object going up against gravity or falling towards the Earth, gravity is 10 meters per second squared. So the unknown is how high will it go, which is a distance. And part B is, will it be higher than it would go on Venus? Okay, so we walk over here to our equation. This is my little think aloud piece. We have initial velocity, final velocity, gravity. We're looking for D. So we look at our equation choices and we get this one. Final velocity squared is initial velocity plus 2gd. And we want to solve for D, so we have to isolate it, and this is how we do it. We subtract rather. We subtract this because we're adding it on this side to this side. So that's how we got this part. Oh, look at that. I left a spot to write it for you. Bear with me. Okay, so the way we did this was, okay, we're going to subtract out this. Then we subtract it from this side. Then to isolate D, we're going to divide by 2g. So we divide by 2g here. That cancels this part out. And we get D equals VF squared minus VO squared. Now what's interesting is, if you think about this, and its final velocity is 0, its initial velocity is flying because it's going upward, this number up top is going to have a negative value, indicating the vector that it's going against gravity. It's going up in the air. Okay, here's our solution. The solution is plug and chug. 0 squared minus 625 squared over 2 times gravity. That gives us negative 390,625 meters squared per second squared, divided by 20 meters per second squared. Okay, square this, subtract the square of that, divide by 20. We get the distance is negative 19,531 meters. That means negative because it's shooting up against gravity. So it would rise approximately 19,500 meters. And then to answer the second part of the question, since Venus has gravity slightly less than that on Earth, which means it would be a number smaller than 10, which then times 2 becomes 20. But our denominator would be smaller than 20, which means it would divide into this numerator more times. So it would actually rise higher on Venus than it would on Earth because there's less gravity pulling it downward. And that is how to solve the Mount Tambora volcano flying ash question.